Okay, so for 3.4, there's really no notes that I'm going to give you. I just want you to write these on a separate sheet of paper. So we're going to look at bivariate data. So one of the most common ways, so everything we've done in Chapter 3 so far has been for univariate data. So this is looking at bivariate data. So I just kind of read this out loud to the class, and then they kind of copy it down. So one of the most common ways to graph bivariate data is a scatter plot. We're really going to get into scatter plots in Chapter 5, but this is kind of just like an intro. If several observations have identical x values but different y values, then the y is not solely determined by the x, but other factors. Again, we'll talk about that a lot in Chapter 5, but if you have like two dots on the same line. So, biggest thing, positive relationship in a scatter plot. As one variable increases, the other variable increases. So if I were to draw you like a little sketch, think of like height and weight. As one variable increases, the other variable increases. So it looks like a scatter plot. I don't know if you can see that. A scatter plot going upward. A negative relationship, as one variable increases, the other variable decreases. So again, positive, I always think height, weight. Negative would be as one variable increases, the other variable decreases. You could think of hours, studying. No, that wouldn't work. That wouldn't work. Hours, not studying. And test grade. Okay, the more you don't study, lower your test grade. So there's that. Horizontal and vertical axes do not always have to intersect at 0, 0. Sometimes it makes it easier to describe patterns in a crowded plot. So, like, if I was looking at height and weight, I wouldn't necessarily start at 0 and 0. I might, like, just look at the class and start at, like, 90 for weight and start at, I don't know, 4 feet for height. Other types of patterns can be described over intervals such as x increases, y initially increases, but after a certain point tends to decrease. So if it's parabolic in shape, we're going to get to in Chapter 5 exponential. So, you know, that would be like as x increases, y increases exponentially. In a time series plot, it graphs data over time, shows patterns and trends. So on page 126 in the book, let me get that out, you can sort of see what happens over time. You've probably seen a ton of these when we had the coronavirus, because they would have like time since first whatever, and then like the chart. So you've probably seen these before at this point. So let me show you one of these. This is a time series plot for transportation. So the year since 1990 and the average transportation expenditure. Here's another one that's a little bit easier to understand. Life expectancy. So years. So from 1940 to 2000, the average life expectancy. So as time goes on, what your life expectancy looks like. So it's just the x-axis is the time, and the y-axis is whatever you're counting. So that's really bivariate data. Like I said, we'll get more into scatter plots in Chapter 5. If you need to copy all of this down, I would pause the video or ask somebody for their notes.